BCA Computer Networks. Unit 1. Attenuation. Attenuation refers to the gradual loss of signal strength as it travels through a transmission medium. This is a common phenomenon in computer networks that affects the quality and reliability of data transmission. Understanding attenuation is crucial for designing efficient and reliable communication systems.
There are several factors that contribute to attenuation in computer networks. The first factor is distance. The longer a signal travels, the weaker it becomes. Next is the type of medium used. Different transmission media, like copper wires, fiber optics, or wireless, have varying levels of attenuation. Frequency also plays a role. Higher frequency signals tend to experience more attenuation. Finally, environmental interference, such as temperature, humidity, and physical obstructions, can cause signal loss.
Attenuation can occur in different types of transmission media. In copper cables, signals lose strength due to resistance and interference. Fiber optic cables experience lower attenuation, but factors like absorption, scattering, and bending can still cause signal loss. Wireless signals are particularly prone to attenuation due to physical barriers, weather conditions, and electromagnetic interference.
Attenuation is measured in decibels, or dB, which represents the ratio of input signal power to output signal power. The formula for calculating attenuation is attenuation in dB equals 10 times the logarithm of the input power divided by the output power.
Don't worry if it looks complicated. Let me break it down for you. Input is the power of the signal when it starts. Output is the power of the signal when it reaches the other end. dB stands for decibels, which is just a way to measure sound or signal strength. So, this formula tells us how much power the signal has lost between the start and the end. You might be wondering, why do we need to use logarithms? Great question. Signals can lose power really fast, and the numbers get big very quickly. By using logarithms, we can scale those big numbers down to something more manageable. For example, if the input power is 1000 watts and the output power is 100 watts, the formula would look like this. Attenuation is equal to 10 times log 10, 1000 divided by 100, that simplifies to 10 times log 10, 10, and log 10, 10, is just 1. So, attenuation is equal to 10 decibels. This means that the signal has lost 10 decibels of power.
A higher dB value indicates greater signal loss.
So, what are the effects of attenuation on computer networks? First, it causes signal degradation, which can lead to errors in data transmission. Second, it reduces the data rate, limiting the speed of communication. Finally, excessive attenuation can result in connection drops, affecting the reliability of the network.
Fortunately, there are ways to minimize the impact of attenuation. One solution is to use repeaters, which amplify the signal at regular intervals. Choosing the right transmission medium, such as fiber optic cables, can also help. Proper cable management, like avoiding sharp bends, can reduce attenuation. For wireless networks, signal boosters are useful. Lastly, keeping cable lengths within recommended limits can prevent excessive signal loss.
There are various tools to measure attenuation in networks. For fiber optic networks, an optical time domain reflectometer, or OTDR, is used. Cable testers help detect signal loss in copper cables. Spectrum analyzers are used in wireless networks to identify attenuation and interference issues. To wrap up, attenuation is an unavoidable phenomenon in computer networks that affects the strength and quality of transmitted signals. By understanding its causes, types, and effects, and by implementing appropriate mitigation strategies, network administrators can ensure more reliable and efficient communication systems.
For more updates, follow the BCA World on Instagram and subscribe the BCA World on YouTube.